Hello folks, my name is Lewis John McGivney. I'm a data scientist at NASA's Jet Propulsion Laboratory in Pasadena, California. Member of the Tagbase project, which is the topic for today's presentation. Just introducing Tagbase as an integrated management and visualization tool for tag data. Okay, what are we covering in this tutorial? Well, we're going to start with the source of Tagbase, which is within our ongoing access-funded project, which is the Oceanographic In Situ Data Interoperability Project, or the acronym OIIP. That leads on to us introducing Tagbase and determining what exactly Tagbase is, where it's developed and who develops and owns it. We'll then cover user and developer level documentation, which leads us quite nicely into the Tagbase server administration, and we covered that topic using Docker. We'll then conclude. Okay, so before we get on to Tagbase, we'll briefly introduce the OIIP project, which is the acronym for the Oceanographic In Situ Data Interoperability Project. This project is founded on the basis that Earth Science Enterprise increasingly relies on the integration of multivariate data from diverse observational platforms to enable research, mission calibration, validation, and decision support. OIIP seeks to enhance technical capacity in this support of its broader objective by developing tools and approaches addressing key interoperability issues that are particularly acute in the field campaign datasets. This is exactly where Tagbase is situated. Okay, so a bit about Tagbase and its involvement, or OIIP's involvement in Tagbase, I should say. So essentially, Tagbase in its simplest form is a relational database management system for e-tag data. And it was originally developed to assist smaller research groups in managing diverse e-tag data sets from devices such as sensors and the like. The enhancements which have been made to Tagbase within the OIIP project is that the entire database implementation has been ported to the open source PostgreSQL. Additionally, we've extended a number of tag-based queries materialized views within the database, which enable really nice visualizations through a JPL developed CMC visualization tool, the Common Mapping Client, another open source technology which has come out of JPL. In the top right hand side, you'll notice that there's a publication which is the primary publication to really learn about Tagbase, its motivation and where it's situated. That publication DOI is included in this slide. It's quite small, but it's also included in the references slides at the end of this presentation. Quick look at what that publication looks like if you're interested in finding it. Hopefully the DOI is quite clear there. But the title, Integrated Management and Visualization of Electronic Tag Data with Tagbase, authored by Tim Lamb and Vardis dos Santos. Okie dokie. Well, let's get on to looking at what Tagbase documentation and source code looks like. Going over to our source code repository, regardless of where Tagbase source code is actually situated. This happens to be within NASA's ECC platform, the Earth Data Code Collaborative platform. However, if you're looking at this source code and it's on GitHub, then the source code repository itself should be more or less identical. You can see here that we have directories for our actual test data, which are available on the server, some database schemas and mapping files, the actual Tagbase server itself, and then a bunch of files related to Docker, composition and builds, some requirements for dependencies, and the README. So if you scroll down when you get to the primary repository, you'll see the project README. And it basically introduces Tagbase as running on the popular Flask application HTTP server platform, providing endpoints for ingestion of various files into the Tagbase PostgreSQL database. So to make this easier for consumption and for users to interact and administer Tagbase, we've deployed Tagbase as the primary mechanism for deployment is on the popular Docker containerized technology. And in a nutshell, Docker enables rapid, simplified deployment of Tagbase by removing more or less all of the services setup configuration, e.g. manually setting up PostgreSQL, manually setting up the Tagbase server, etc. And this is achieved through utilization of Docker Compose, which is a very nice, convenient administration tool for composing anything from simple to complex software architectures. So essentially, all that you're required to download in order to run Tagbase, the Tagbase stack, is Git if you're planning to check out the source code from a remote repository, or either to download a zip file, which will download the most recent master revision of the source code, and then Docker. If you're planning to download the zip file, this hyperlink here will always link to the most recent development version of the code base, which we always try our best to keep stable. And it should be mentioned that if you are just downloading from the zip file, then the only technology you actually need to install, the only prerequisite software, is Docker itself. So moving on, once you have downloaded the source code, you can navigate into the top level root directory for Tagbase server. So that's exactly what we've done here. In my terminal, you can see that I'm in user local Tagbase server, and this just indicates that I'm on the master branch. Going back to the README, we move on to see how it would actually be deployed. And there's some memory considerations for Docker here as well. By default, Docker for Mac and Dockers for Windows set a runtime memory allocation of 2 gigabytes per container. And in our instance, we launch containers that we wish to exceed this 2 gigabytes memory allocation. And it's important for me to demonstrate just now in Docker. If you're installing Docker for Mac or for Windows, then you should see this Docker icon in your top toolbar. If you navigate to Preferences, you'll then see that if you go to, in general, if you're to navigate to the Advanced tab, you would see that you have the ability here to increase the memory allocation per container from the default of 2 to something like 4 or maybe more. 4 for the time being is an adequate memory allocation. It should be noted that when you do increase this, you'll be prompted to restart the Docker engine, which is exactly what you should do. Going back to the README, you'll see that this is quite an important prerequisite step to allocate sufficient memory. But once sufficient memory is available, to orchestrate and deploy the Tagbase services, execute the following commands from this root directory. So you can see on the right hand side here that on my terminal I've already executed docker/compose build, and what that has gone and done is it's orchestrated the build for the Tagbase stack. What that Tagbase stack essentially comprises of is a base PostgreSQL image with the Tagbase schema preloaded into the database, such that when we actually deploy the software stack, we already have all the staging tables, we have certain trigger functions established in order to migrate data upon a successful ingestion task of eTag data, and our materialized views, etc. So essentially, you would go ahead and build, which I've already done. Going back to the README, once you've built the stack, you would then go and actually deploy that software stack. So let me just go and do that just now. Docker compose up. You can see that we've created the PostgreSQL server. We create the Tagbase server itself, and then we provide a pgadmin interface, which enables one to actually directly interact with the database very simply, very easily, and very intuitively. So kicking down through some of our tag information here, you can see that the PostgreSQL server is ready to accept connections. Earlier on, our Tagbase server was also deployed, and you can see here that the pgadmin interface is also listening at port 80. However, for purposes of this tutorial and for ease of the Tagbase server deployment, we've actually mapped this port 80 to another port, and I'll go and demonstrate that in a second. So, after a short while, you will now have a completely Dockerized deployment of Tagbase master branch, PostgreSQL server 10 and above, and the pgadmin interface. You can see below for accessing web applications. However, it should be noted that in order to stop this stack, all you would do is open another terminal, navigate into the Tagbase server repository, and you would execute docker / compose and then the command stop. You would then see the services graciously shut down. Okie dokie folks, well, moving on to accessing Tagbase server now. You'll see here that depending on which platform you're running this, whether it's Windows or Mac, you may have to navigate to either localhost or 0.0.0.0, and this depends which workstation you're actually working from. In this instance, what I'm going to do is copy the URL here, and because I'm working from Mac, I'm going to change to 0.0.0.0:5433, which is the port which Tagbase server is actually, the interface is exposed from. We've versioned the API at version 1 currently. The service is Tagbase, and we're indicating that we want to navigate to the user interface. So if we type that in, what we'll see here is our primary entry point for interacting with the Tagbase server itself. Some of you acquired and familiar with the Swagger technology for REST API development will notice that this application here is simply the Swagger UI, the user interface. And what you'll see listed here are a number of endpoints. The endpoint that we're interested in today is the endpoint for ingest of eTUF data. You should see that there's some implementation notes. There's documentation on responses that you should familiarise yourself with. Most importantly, however, you'll see that there are parameters which are included here. The first parameter is granule_ID, which is described as an arbitrary unique identifier for the file that you wish to ingest into Tagbase. And we've given an example here of 888, but for the purposes of this exercise, we'll just put 1. I know I have nothing else in the PostgreSQL database, so we can start at 1. The second parameter that you'll see here is just file. And what we're looking for the file here is the file we wish to ingest into the PostgreSQL database. The description of this parameter is the location of a network accessible. So this parameter value can either be file protocol, FTP, HTTP, or HTTPS. And it should reference an eTUF file. As I'd mentioned previously, when you look at the source code repository, if I scroll up here, you'll see that there is some data already deployed into the source code repository. That data there references the test sailfish file. It's a smaller file, which means that it's ideal for exercising our demonstration today. So let me go ahead now and just show you exactly what that looks like. For convenience, we've posted the sailfish file below in our documentation, and we can paste that in here. In the Docker container, this file resides at user source app data. It's as simple as that. Okay, let's try it out. What you'll see here on the right hand side is a progress bar, or at least an activity bar to let us know that a process is executing. If we go over to our terminal, you should see here that the Tagbase container is logging input. You should also see here that we eventually will receive a response, an HTTP response code. Let's wait until this is completed. We should see that response code quite soon. The nice thing about this user interface as well is that when it does finish, we will see below what kind of response we actually receive. In the meantime, let's go back to our documentation and have a look at more information relating to the execution of the ingestion tasks. Tasks can also be executed via common command line tools such as curl, or essentially via just an HTTP GET request when you pass in the parameters and the values you associate with those. And again, we've noted here that the REST server is capable of ingesting data from many sources, whether it be file, FTP, HTTP, or HTTPS. In the meantime, what I would like to do here Okay, we'll go back to the interface. We can see that we've had an HTTP response code of 200, which means that it's a success. The response body itself has indicated that the data file ETUF sailfish in read-only mode with a particular encoding has been ingested into Tagbase. Time took to ingest the file was just under 50 seconds. What's actually happened here is that the ETUF file has been ingested into the Tagbase database. You can see here that we also have a 200 response code in the container logging. The file has been ingested into Tagbase, into the initial staging tables, and a migration trigger has been activated, which has populated some of the information from the initial staging tables to migratory tables. And what we're talking about here is the creation of the proper time series and various other bits and pieces related to Tagbase. These are detailed more within the primary publication, which was covered at the beginning of this presentation. Okay, so how do we verify that there is actually data within Tagbase? Let's go back to our README. We provide a pgadmin interface for this as well. So let's browse to the pgadmin interface and have a look. Okay, the primary point of entry for the pgadmin interface is the username Tagbase and the password Tagbase. You can then log into the database administration interface and add a new server, which we'll call Tagbase. You can see that there's an error or a warning which has appeared at the bottom. Either a host name, address or service must be specified. So let's therefore go over to the connection and establish our Postgres, which is the host which the Postgres container is referenced by, and the port 5432 is exactly where we want to be. Username Tagbase is fine. We can save that database configuration for the server. Once we connect to the Tagbase database, you can then see in the bottom right hand corner that we've connected to the database. We can then browse into our schemas and then into our tables, and you'll see that we have a number of tables which have been created here. If we go to submission and open up our query tool and then just query, select all from submission, we should see one entry here, which we do have, which is essentially the submission ID, which was number 1, and then our file name, which is the same file which is present on the Tagbase server and accessible through the Swagger UI. Okay, great. Let's get a bit more adventurous here and have a look at some of the other tables that are here. So if we look at the data time series and we'll limit it to 10, what we should see here, well actually let's do a count to see how many observations that we actually have. So there's 130,704 entries within that response, and this is one of the reasons this sailfish file is quite a small file in comparison to some of the other Tagbase data which researchers tend to acquire. Hence the reason that within the Docker engine we wish to increase the memory associated with that there. Okay folks, essentially at this stage what we have done is we've managed to ingest data into Tagbase, and our trigger function, which is present here, has executed a data migration for us. We're now ready to essentially create materialized views. Our documentation here says that upon successful ingestion of files into Tagbase, you're required to generate materialized views in order to access the application-ready Tagbase data. What we mean by application-ready is essentially just visualization. We've also noted here, previously it was necessary to execute a data migration command, which essentially populated initial staging data around the database. This is now managed by a trigger, which I just showed you, such that all we need to worry about is generating materialized views. So, how do we generate materialized views? Well, you can generate the Tagbase materialized views by simply opening the following file, which is included as a hyperlink, or I'll open it from my text editor. Let me do that just now. Let me make my terminal slightly larger for everybody. I'm in Tagbase server, I'm using Sublime Text to open SQLDB, Tagbase, materialized views.sql. Okay, excellent. What we can see here is that we have all of our materialized views here, all 130 odd lines of. So we copy that materialized view. We then head back over to our pgadmin interface. We delete anything that was present within the query tool. We paste in our materialized view, and we simply execute that materialization. You should then see that we have essentially populated data into these materialized views, created the materialized views and populated data, and you should have a response time for the query. When we then go to open our materialized views, you'll see that we now have a number of materialized views which have been created. At this stage, it's always nice to be able to perform maybe a count on mview viz data. We can see that there's one entry in this table. If we were to my apologies, there's 87,000 entries in this table, and if we have a look at what one of these entries looks like, we can see that we have a source ID from the initial file which we ingested. We have a measurement value, measurement name, the unit of measurement, the depth, measurement date time, position date time, a latitude longitude, a latitude error and longitude error. And if we scroll down, we can see that these errors may populate further down the database table, as you can see. So essentially our materialized views in this instance are fully populated, ready for visualization. Okay, going back to our documentation, we can essentially say that similar to the ingestion and migration routines, generation of materialized views may take a while, so please be patient. This is dependent entirely upon the size of your input data. Some of the other files that we've been working with locally can have millions of rows. So the time is dependent exactly upon the size of your input data, so please be patient. It should be noted, however, that materialized views can only be generated once. So the logic here is that you ingest as many files as you require, or as much data as you actually have. You would then run the materialization process. You would not run a materialization process for every ingestion process, because once these materialized views have been generated, we cannot generate another materialized view over that particular materialized view. So that's quite important. That may be a feature which we build into Tagbase in the future. However, right now, you will receive an error if you try and create a materialization for each ingestion task. Okay, well essentially we've come to the end of the demonstration on Tagbase server. It should be noted, however, that at the bottom we describe how you can run Tagbase manually. This would not require you to download the Docker for Windows or Mac. It would, however, require you to download and administer the PostgreSQL database and all the configuration associated with that, the Tagbase and all the configuration associated with that, and then the pgadmin tool and all the configuration associated with that. So hopefully you can see the value that bringing Docker and the container platform to Tagbase really provides for users and administrators. Okay folks, and finally, development support and community. Please either head over to the Tagbase repository, which I believe will be on GitHub, or reach out to the OIIP team at oip@jpl.nasa.gov. Okay, finally, back to my presentation. Conclusions are that we introduced very briefly what the OIIP project is. We then went on to describe what Tagbase is, where it's developed, and who develops owns it. Tagbase is essentially an open source project, so the people who develop and own it are anybody that's involved with that open source community. Number 3, I introduced the user and developer documentation. Number 4, I went through administration of Tagbase server and the associated software stack using Docker. And finally, we're just concluding. So with that, I'd like to say thank you very much. Any questions you have, please lodge them at the associated issue trackers, which are provided in the next slide. For any questions on the OIIP project, please contact us at oip@jpl.nas.gov, or else please contact myself directly at lewis.j.mcgibney@jpl.nasa.gov. And finally, your references for the OIIP website, for the NASA Access Programme, which OIIP was funded through, and the work on Tagbase here was funded through, references to the Tagbase repository on GitHub, and finally the DOI for the journal which essentially introduces Tagbase. Very final comments here is that we would like to acknowledge funding and support under the NASA Access Programme, grant number Access 15-017. Very much acknowledged. Thank you.